Hello dear students, let's see this question of IIT-JEE 2012. It's a multiple choice question. The question states, in the given circuit, the AC source has omega is equal to 100 radian per second. Considering the inductor and capacitor to be ideal, the correct choice or choices is R. So we'll see each choice one by one, and let me draw my own diagram also. So this is the diagram of the question. We have to find in one of the option I. If nothing is written, the I is the RMS value, and then in one of the option the potential difference, voltage across the 100 ohm and voltage across the 50 ohm. So this I that we have to find is the RMS value, and right now what I will do, I will get the instantaneous value and then convert to the RMS value. So suppose at any time t, the instantaneous current here is say I1, and instantaneous current here is I2, and this instantaneous current is I, and let me assume this instantaneous voltage, the peak voltage was how much? This was given to be 20 volt. So the peak voltage, this again nothing written, mean it is a RMS value. So the peak voltage is 20 root 2, and I am just assuming this variation to be sine omega t, and omega I am writing as it is, that is not required, only for the I am writing this to get the phase difference between I1 and I2. And before that, let me get the XC for this and XL for this. So XC would be 1 over omega c, because this is actually these two are getting the same voltage and these two are also getting the same voltage. So 1 by omega c. So 1 over omega is 100, and this is 100 microfarad. So micro will go into numerator to become 10 to the power 6. So that is 100 ohm. And XL for the inductor, XL is omega L, omega is 100, L is 0.5, so that is 50. So for this circuit, I am taking two parallel circuit, like this one is getting the voltage and these two are getting the voltage. So for these two as a whole, I am drawing the phasor diagram. So phasor diagram for this part, I can directly write their Z. Their Z for this part will be simply how much? 100 root 2 ohm, and Z for this part, this XL is 50, so Z for this part will be 50 root 2. So now here I want to find the I1, and for I1 I need to get also the phase difference between this voltage. So for the upper part, if I plot, so resistance is R is 100, and XC is here, X is also 100, their resultant is Z, so that Z is 100 root 2, and we should remember that this is actually the voltage along the of the resistor, and this is along the phase of current, and the Z is along the phase of voltage of the source. This is 100, this is 100, so that would be 45. And if I want to write these peak value of current will be the peak value of the source voltage divide by Z. So for the first circuit, so peak value of the source is 20 root 2, and peak, and the Z1 is 100 root 2, so that will be 0.2. And now the instantaneous current I1, the peak value of the current, and this current is a pi by 2 ahead of the source voltage, and this was the phase of the source, so this current will be 0.2 sine omega t plus pi by 2. And now for this current, I'll draw another phasor diagram. There is a resistance R, 50 ohm, inductor as a inductive reactance XL, 50 ohm. Their resultant impedance 50 root 2. This Z2 is 50 root 2, and along Z2 there is a Vs, and along R there is a I, and that I is I2. And this 50-50, so this angle will also be 45. So the peak value of current I2 would be peak voltage of the source divided by Z2. Peak voltage of source is 20 root 2, and this Z is 50 root 2, so that would be 0.4. So now the instantaneous current I2 would be the peak current 0.4 sine omega t. The phase of this current is pi by 2 behind the source voltage, right? This is the phase of the source voltage, so this phase of I2 is pi by 2 behind, so minus pi by 4. And this instantaneous current is the sum of these two instantaneous currents, so I is equal to I1 plus I2. I can do this I directly, because what I am interested not in phase, the RMS value. Before RMS value I'll get the instantaneous value. These two are SHMs. Its amplitude is 0.2, its amplitude is 0.4, same omega. The phase difference is pi by 2. So the peak current I naught will have, if there is a 2 SHM A1 A2 amplitude and phase difference phi, same omega, their resultant amplitude is square root of A1 square plus A2 square plus 2 A1 A2 cos phi. So phi is pi by 2, cos phi is 0. So the amplitude of the resultant current, that will be 0.2 square plus 0.4 square. But what we are asked is I, and nothing is written. I told that is the RMS value. So the RMS value I is the peak value divided by root 2. So that would be 0.2 square plus 0.4 square divided by 2. And if we solve it, so we'll get it approximately 0.2, 0.3, slightly more than that. So I'll take 0.3 ampere. And let me see the option. So option A is correct. This is option A, and this is correct. So B cannot be correct. Then it is as the voltage across the 100 ohm resistor. This is the 100 ohm resistor. Here the current I1. This is the current I1. This current I1 has a peak value 0.2. So here the peak voltage would be the peak current into resistance. So VR, this V100 peak value would be how much? 0.2 into 100, that is 20. So if whatever is asked, if nothing is written, so we mean that is the RMS value. So RMS value of that thing would be 20 by root 2, so 10 root 2, and that is the option C. So option C I'll mark a correct option. And then the voltage across 50 ohm. So here I2 has a peak current 0.4. So 0.4, so the voltage across this 50 instantaneous voltage, the peak value of this voltage will be 0.4 into 50. So that will also be 20 volt. And then this RMS value will be 20 by root 2. So that will also be 10 root 2 volt. But this is given to be 10. So this is incorrect option. So the two correct options are A and C. Thank you.